All right, so we're going to go over questions. We won't call this section. What do we call this? Study guide? Study guide and review. I'll just say study guide. And this was chapter, 11? Okay, so we're just going over questions. We just read off all the answers, so let's just go over questions on any of these things from the study guide. Is there anything before that last little section that you want to ask about, Brad? 17. Okay, we'll just kind of mark down some numbers here. If you see something that you got wrong, you don't know why you got it wrong, or if you just didn't know how to do it in the first place, those are the ones you should be asking about. Don't just throw out random numbers, please, okay? Make sure you actually kind of looked at it for at least a couple seconds before you ask about it. Anything else besides 17? 23? Okay, 25 to 27. 24. 23 to the end. Anything else? 16. 16? You sure about 16? Did you really try 16? Same thing with 17. Same thing with 17. There's really no issue with 16 and 17. You just have to know the formula for area of a trapezoid.
765 for 17, and I got 200.
Did you take half?
Yep.
I don't know. Did you multiply the bases or add the bases? You probably multiplied the bases. You add the bases.
Okay, well.
Look, area of a trapezoid, I'll just put trap, is 1/2. It's 1/2 the base times the height. You remember how you can remember it's 1/2 the base times the height? Because trapezoid starts with what? What's it start with? What is trapezoid? What letter does trapezoid start with? T. It doesn't start with trap. It starts with T. My gosh. I better stop recording because I may say something that I don't want recorded because stuff like that just ticks me off. Look, it starts with a T. What else starts with a T? I went through on that lesson when I taught this lesson. I said it a lot. Triangle? Because you didn't watch the lesson, obviously. Okay? Alright. Oh my gosh. Okay, look. I'll say it now. Guys, sure, we'll just completely stop doing this. And then you're on your own for the test. I'm fine with that. It's less work I got to do. Everybody okay now? Alright, settle down. Trapezoid starts with a T. Another geometric figure that we've been talking about is triangle, right? Starts with a T as well. Well, what's the area of a triangle? You should know that. It's 1/2 the base times the height. Trapezoid is kind of like triangle, and it's easy to remember because they both start with T. Instead of 1/2 the base times the height, how many bases does a trapezoid actually have? It's got 2. So what do you do with those 2 bases? You add them together, okay? You add them together, you get one big base, right? So it's still 1/2 the base times the height. You just add the 2 bases together on the trapezoid. So for number, I don't care which one we do. Both 16 and 17 are almost identical. They're just different numbers. Let's do 16. So the area is 1/2. The 2 bases added together. So on number 16, which one are the 2 bases? Look at it. 8 and 4. Okay? 8 and 4 on number 16. That's the 2 bases. 8 and 4. They're the parallel sides. The parallel sides are the 2 bases. Okay, times the height. What's the height of this trapezoid? It's 14. Okay? What has to be true about the base and the height? They have to be what to each other? Come on, we haven't said that one time. Come on, somebody that's actually paid attention, answer. All right? The base and the height have to be what? Not parallel to each other. Perpendicular to each other. Perpendicular to each other. So, anyway, watch. That's 12. And that's 14. You can do this in your head, can't you? You could go half of 12, or you can go half of 14. I'm not going to go 12 times 14. Can you do 12 times 14 in your head very easily? Nathan, you might be able to. I can't do it in my head very easily. I mean, I could figure it out, because 12 times 12 is what? 144, right? And then you got 2 more 12s. That's a 24 on top of that. You could do it that way if you wanted to. Okay, or you could go, let's do it like this. Half of 14. What's half of 14? 7. And you should know 7 times 12. And what's 7 times 12? How about 84? Okay, so you could do it that way if you wanted to. And that's it, right? Isn't that the answer? Yep, should be. And then it's feet, so it's feet squared. That's all there is to it. You got to add the two bases. That's the area of a trapezoid. So that takes care of 16 and 17. It's just a matter of knowing your formula. Okay, there's nothing tricky about that at all. Let's take a look at number 23. Let's take a look at 23. All right, let me pause this while I read it. All right, here's our circle. And it says a bicycle tire. I assume the bicycle tire is circular. Okay, it'd be kind of weird shape or weird tire if it wasn't circular. It says a decoration. You're decorating. Why would you decorate your tire? I have no idea. Anyway, it says it covers 1/9. Shh, don't talk. Don't talk. It's a rhetorical question. Didn't require a response. So it says it covers 1/9 of the circle formed by the tire. All right, so here's a circle. It's a bicycle tire, and it says a decoration. It covers 1/9 of the circle formed by the tire. Okay. So where's 1/9? So yeah, we could figure out. That's a good idea. So 360 divided by 9 would give you what? 40. So it covers 40 degrees of the circle, doesn't it? Okay. And let's put our center here, right there. And so we'll just estimate, because they don't give you a picture, do they? So we'll just estimate what it looks like. Okay, so it covers 1/9. So just this little part right here. I don't know. I've never seen a decoration for a tire. I have no idea what they're talking about. But anyway, it covers 1/9 of the circle formed by the tire. The tire has a diameter of 26 inches. I don't really care about the diameter, do I, on a circle? What do I care about? The radius. So if the diameter is 26, what's the radius? It's 13. So I'm going to use 13. It says, what's the area of the decoration? So what's the area of just this part right here? That's what they're asking for. Okay, and what is the angle? It's 40 degrees, or it's 1/9, right? You could just take divided by 9, or yeah, or you just use the 1/9. You don't even have to use the 40, do you? You don't even have to know that that's 40. So it's 1/9 of the whole entire circle. Well, what's the area of a whole entire circle? It's pi r squared, isn't it? And the radius is 13. And so it's just 1/9 of that. So you could, if you wanted to, you could figure out it's 40 and then go 40 over 360. But what's 40 over 360 anyway? As 1/9. So it's kind of out of our way, isn't it, to go through all that? So it's just 1/9 of the whole circle. So you just plug that in your calculator and you should be good to go. So let's see how to do that. See how you got the 1 over 9, the 9's on the bottom? You could just do this. You could just put that whole thing over 9. It's the same exact thing, isn't it? If I multiply it by 1/9. Sometimes that makes things a little bit easier for somebody, I guess. I don't know. So what do we got? 13 squared. And then pi. And then divide that by 9. That should be the answer. Yep, because they said 59 inches. We'll round that to 59. So 59 inches. This is 23. All right. It's inches squared, by the way, because it is area. That's all there is to it. Wasn't that big of a deal, was it? Pretty easy. Yeah, you're not taking 1/9 divided by 360. It's 1/9 of the whole circle. That's what I would do. I would do 1/9 of the whole entire circle. See, that's what you're doing right there. That's what I would do. We good with that? All right, let's go on to the next one. What do you have, like 24 to the end, right? Oh, you guys didn't even say the 30s, did you? What's that? Yeah, we went over all the answers.
No, for the test tomorrow.
No, that's
on a video.
It's on the video. You have to watch the video for that. So let's do let's skip 24. Let's not do that one. Let's do 25. And that's how many sides? Hexagon? Okay, here's the picture. This is number 25, right? Number 25. All right, you got to find the area of this thing. Well, it is a regular. They tell you it's a regular Actually, they don't. They should tell you. It just says find the area of each figure.
Regular polygon.
But the title of it says areas of regular polygons. They should say it's an area of a regular polygon. It does say it in yours? See, it doesn't say it in my book.
Which one?
On 25 above it, mine just says find the area of each figure, and that's it.
That's what it says.
Yeah.
Regular polygon or.
See, some say regular polygon, and some books don't say it. So,
Well, no, it says in the
That's-
title areas of regular.
well, that's what I'm saying. In the title it says it, but in the instructions, it should say it in the instructions that this is a regular polygon. But Cole, yours does say it.
Mine says regular.
Yeah, I know. We've seen that before. We've seen that before. What I'm going to do is this. Watch. I'm going to put a few lines here, and I hope you guys are watching. Okay, you guys are all giggly like little girls or something. Okay. I'm sorry, but just boys giggling just gets on my nerves so much. I just can't tell you how much that bugs me, especially when I'm trying to teach you something. All right. So watch. I'm going to put these two lines right here, and I'm going to put an apothegm in here. So I'm going to start off putting some things that I may possibly need to know. All right. I'll call the red one A for apothegm. And they tell us this is 8. Now, it is a regular polygon. They're supposed to tell us that. It's a regular polygon. So I know the whole bottom of this is also 8, correct? What does the apothegm do to one of the sides, to any of the sides? It bisects it. So what I have here is I have a right triangle. Okay, I'm going to use that right triangle, do some stuff with that right triangle, and I know the length of that little part right there. Okay? But that's the only thing I know. It's the only side that I know. I don't know the length of the apothegm. I don't know the length of that yellow one. Why did I even put the yellow stuff in there? What's even the purpose of me doing that? To find a what? Yeah, it does give me a hypotenuse. That's true. But look at that angle that's formed right here. Why do I care about that angle? Right, I need it to maybe do some trig with this. Watch. I'm going to do... You don't have to draw all these. Okay, I just did. But look, 1, 2, 3, 4, 5, 6. There's 6 angles. It's a regular hexagon, so that kind of makes sense that there would be 6 angles inside of here. And they're all evenly spaced because it's a regular hexagon. So how do I know each of those angles? 360 divided by 6. That's right. And what does that give us? 60 degrees. So each of these big angles right here is 60 degrees. But what does that apothegm do? It bisects that angle, doesn't it? Okay, bisects this segment, it bisects this angle. So if the whole angle is 60, then what's this part right here? It's 30. And of course, if that's 30 and that's 90, then that has to be 60. So we have a 30, 60, 90 triangle. You could use your trig function on this, but do you really want to use your trig function on this? You could do it much easier, and the whole reason we did this on this chapter is so that you could do this easy without any calculator, really. So look, this is the short side. What are we trying to find? Trying to find the apothegm. By the way, you know what? I should have done this right off the bat, and I didn't. But we do have a formula for area. What is the formula for area of a regular polygon? What is it? Is it? It's 1/2. It's 1/2 the perimeter times the apothegm. Okay, you got to remember your formulas. I'm not giving you formulas on the test. You have to memorize them. All right, it's 1/2 the perimeter times the apothegm. Now look, I could find the perimeter right off the bat just by knowing the length of this outside part, couldn't I? So it's 1/2 of the perimeter. What would the perimeter be if this was 8? How many sides are there? There's 6 of them, so it'd be 48, wouldn't it? So that's the perimeter right there. So really, what's the only thing that we really have to find? It's the apothegm. So now that I have this, now I can find the apothegm. How am I going to do this with a 30, 60, 90? This is the short side, and what's the apothegm? You got it. So the apothegm is 4 times the square root of 3. Because the long side is the square root of 3 times the short side. See how easy that is? And so you can just put that right here if you want. 4 square root of 3. And now it's just a matter of sticking that into a calculator. So let's do that. So we'll wait to the very end to put stuff into a calculator. That's what I like to do anyway. You can do a little bit of this in your head. What's half of 48? 24, right? So it's 24 times what? 4 times square root of 3. Does that work? If you wanted to put half of 48, you could, but I just decided to do that. And there it is, 166.3. That's exactly what they said. It's always nice when we get the same answer that they do. And it's in feet, so it's feet squared. There you go. That's the area of that whole entire thing. It's not the area of just that triangle. It's the area of the whole entire thing. Make sense? It's not so hard, is it? Once you realize this formula, once you know this formula, and you know where to draw those lines, draw the apothem, draw these things right here to make a triangle out of it so that you know what that big angle is right there. You had to find that angle by 360 divided by 6. You got the big angle, you know that bisects it, so that's half of it. And then there you go. You're not always going to get a 30, 60, 90 triangle out of this. All right? You may get something, like if you had a pentagon, you wouldn't get a 30, 60, 90. You get something else. But you might have to do some trig. You might have to do law, or not law, but you might need to do cosine or sine or tangent, whatever the case may be. All right? I'm not going to do every single one of those, but let's do number 26 is still no, it's an octagon, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. Yep. And I'll tell you, let's do 26. Let's do 26. Let me go grab an octagon. All right, here's the problem. Now we have an octagon, 8 sides, but look what they tell you. They don't tell you the outside part this time. They tell you something a little different. They tell you this, I don't know if they even call it. It's not really a radius, but it's kind of like a radius. I don't know. It's a line from the center to a vertex, okay? And we got to find the area of this thing. So again, we're going to use the same formula that we used earlier. But now it's not quite as easy to find the perimeter of this thing because they don't tell us the outside, do they? So we're going to have to find the outside and we're going to have to find the apothem. So that we got to find two things now, whereas before it was pretty easy. So I'm going to set it up just like I did the other one though. What am I going to draw in here? Draw lines from where to where? Yeah, let's draw this triangle first right here. Okay, I'll stay in the same color scheme as we did before. And then what am I going to do here? Draw from here where? Let's perpendicular, right? Don't say straight down because I could have drawn it, right? I could have drawn it here. That's not straight down, is it? Or I could have drawn it here. That's not straight down, but I draw it perpendicular. So there we go. And what's the first thing? Now I've got stuff drawn, but that doesn't really help me. Well, it helps me a little bit. I know the hypotenuse to this right triangle now, don't I? What is this hypotenuse, this yellow? It's 6, right, because it's the same thing as this one was. Why didn't I just draw it here and just make that part of it? I don't know, just to be consistent. It's just, to me, it's a little easier seeing things like straight up and down instead of kind of crooked and sideways. You follow me? So that's why I drew it like that. That's really the only reason. Some people might have drawn it to here and dealt with that triangle right there. I just thought it just looks a little prettier just to make it like that. Okay? So now what do we need to find? We need to find the apothem. And we also need to find this little bit right here, don't we? I'll call it B. Is that all right? If I find this little bit right here, then I can find the whole entire side because I just double it and I got this. Then I multiply by 8 and I got the whole entire perimeter. Everybody see that? So if I can find this little b, basically I just multiply by 16 and I got the whole perimeter. Everybody with me? Well, where do I start? That's the only number I have is a 6. How can I even work with this if that's all I know is that's a 6? Okay, yeah, I can find that angle right there, right? And Jacob said 360 divided by 8. What is that? 2 is 180, 90, 45. Is that 45? 45. Yep. 45 degrees. But that's not this angle, and it's not a 45, 90 triangle, is it? This is 22.5 degrees, that little angle right there, right? Because I took half of 45, because this bisects that angle. We good? All right. Now, can you do a special right triangle thingy? Well, actually, if this is 45 and this is
90, 45, 45.
no, I don't know. Let's just do it this way, okay? We don't need to find any other angles. As long as we know that's 22.5, we're good to go. So what am I going to do to find A? Let's change the color here. Cosine, good. Cosine of 22.5. How did I know to use the cosine? Because it's what? It's adjacent over hypotenuse. So it's adjacent over hypotenuse. That's why I use cosine. Solve for a, multiply both sides by 6. There's the apothem right there. And then you can take that and plug it into your formula, the 1/2 PA. Once I get that, then I solve for b. Let's solve for b. What am I going to do for that? We're using trig functions. Might as well just use a trig function again. This is opposite in hypotenuse, so use the sine of the angle is equal to opposite over hypotenuse. Multiply both sides by 6, and there's that. So let's just finish it off. I guess we'll do the whole thing here. So it's 6 cosine 22.5, and that's 5. Let's say 5.4. Let's go 2 decimals. 5.54, and let's do the same thing, but do it with sine this time. So it's 6 sine of 22.5, and that gives us 2. Let's go 3 since the 6 rounds that up. So we'll go 2.3. Okay, just wait. Let me finish this problem first. 2.3. All right, so that little bit is about 2.3. So we know the apothem. We'll just say 5.5. Is that all right? We'll go 1 decimal. So let's do this. A equals 1/2 the perimeter. How do we say we're going to find the perimeter? Take that 2.3 and do what to it? That's only... Yeah, I go by 16, because you're going to go by 2 to get one side, and then by 8 to get the whole thing, right? So you might as well just multiply it by 16. Everybody with me on that? So that 2.3 times 16 is actually your perimeter. We still have to multiply that by the apothem, which we already found, which is 5.5. So now it's just a matter of chucking that all into your calculator, and hopefully you'll get the right answer. So it's what? 0.5 times 2.3. Excuse me. That was probably loud. Oh, I sure did. 0.3. Is that right? Times. Oh, what am I doing? Why am I putting 22? I don't know. 2.3. Okay. Times 16. Am I right now? Okay. Times 5.5. 101.2. Is that our answer? It's pretty close. They said 0.8. Why do you think they got a 0.8? We got 101.2. That's what we got, and they got 101.8. Does that mean we're wrong? Yeah, the rounding. Okay, I'm not sure where they really rounded. They may not have rounded this at all. They might have actually taken this full number in the calculator, stuck it in here. Okay, I'm not really sure how they rounded it, but this difference right here is just a matter of rounding. So if you got that, that's fine. If you would have gotten this, that would be fine as well. Just 239 would not be a rounding issue. Okay, if you're off a few decimals, then that's probably just a rounding issue. If you're off a couple hundred, no. 103? Doubt it. You probably did something wrong. You have to figure out what you did wrong. I doubt 103. I think you probably made a mistake somewhere. I doubt that's just a rounding issue. All right, enough of that. Let's go to, what do you got, like 4 minutes left? What's the one everybody, let's do 30. Let's go to 30. Well, that's what we thought, but we got a lot of incorrect answers. So let's see if it's the book. Let's see if it's the book or if it was us. Or you, since I didn't do these problems. Alright. Why is that so funny? I don't understand. Just because I laughed a little bit. You guys giggle over the dumbest things, I tell you. I just don't get it. Alright, they make this one green, didn't they? So let's make it green as well. Stick with that color scheme that they have. Let's see. They say that this is X. And this is, the area. They tell you the area of this is 30. They tell you this side is 5. And they tell you the area is 40. And it says that these are similar triangles or similar figures. Okay, do you remember Remember the thing with similar figures? What do? We set up a ratio, don't we? So we go x to 5. But what does the formula say we do? We square them. And that should equal the ratio of the areas. So it should be 30 to 40. Is that how you set it up? Okay. You still might be able to do that, but you still have to square the x, and you still have to square the 5. All right, so it's just a matter of doing this. So it's 40x squared equals, watch this. I'm just going to 30. Yeah, it's cross multiply. There's an equal sign, right? Or you could just take this and multiply by 5 squared over here. You could have done that. That would probably have been the best way to do it. You see that? Multiplied by 5 squared. You still get the same thing.
That's what I did.
All right. So anyway, what do we got here? It's 30 times 5 squared. Still works out the same way. And then divide by 40, right, to get rid of this. And then what do you do to get rid of that square? Not square it, square root it. So that should give you your answer. Let's see if it does. I'm going to do this. I'm going to go 30 times 25. Divide that by 40. That gives me that. Then I'm going to take the square root of that. Square root of my answer. Oops, I did something wrong. Let's clear that. Square roots of my answer.
Hi, seniors. We are not meeting today because so many people left for sports. We are meeting tomorrow.
That is not the answer they give on the book, is it?
That's what I got.
Thank you.
Yeah, so they did something wrong. They probably didn't write the problem correctly, is what I'm thinking. But that should be the answer. But it also says find the scale factor from the blue to the green. It should just be, well, whatever your answer is over 5 should be your scale factor, right? Or you could just go, or let's see. Yeah, I guess that's the only way to do it, right? You find x and you put that over 4.3 squared over 5 squared, whatever that is. I got a weird answer for that. I'm not really sure. Okay, so remember, we changed the test till Wednesday. It's not tomorrow, okay? So we changed the test till Wednesday. No, you're going to hang on to those. Study guide, I always collect the day of the test. All right? You don't have homework. So go over. Now watch. Listen to me. You kind of have homework if you want to do well in the test. Watch the video that I went question by question on, because I'm not going to do that with you guys, okay? You guys have to watch the video if you want to see that.